y'all, back with another video. Today I'd like to talk about coolant. So I bought this mill, the SYIL X7 in 2020, and I'm finally running coolant. I mean, it's been less than a week. It was an interesting process. There were a few hiccups, and I thought I'd go over my thoughts on that. I've got a list. Here are my thoughts on coolant. I've got it organized into first leaks, second oil coolant separation, and then lastly the machine setup for everything. So first off, leaks. I wanted to make sure that I didn't have any leaks in the tank, and I'm glad I did that. All in all, I probably filled this thing up 3 or 4 times just to make sure that I wasn't leaking any water before I went ahead and mixed up the tank. The first leak that I found was in this drain plug supplied by SYIL. This is the one that came on the tank. No matter how much of Teflon tape I put on here, it leaked. So I ended up buying a new one, something with longer threads. Longer meaning just they had more thread length from start to finish. Once again, I tried with Teflon tape. It leaked. I tried putting more Teflon tape on twice, and it still leaked. It seeped out. In the end, I went with pipe sealant. The pipe sealant I just got at the local tractor store, T+2 pipe thread sealant. So I went ahead and applied this to the inside of the threads and the male threads, the female and the male, and then put my new drain plug in, and it didn't leak from the start. So for me, this was a game changer. The second leak that I found was in the sight glass. So here's the sight glass that came with the machine, and I don't know if I was leaking from the top or the bottom. These bolts go all the way through this sight glass housing, but it was leaking out this, and I couldn't get it to stop. So I removed this, and then I just blocked up the holes. I ended up going with these washers from McMaster Carr. I bought 2 7/16 304 stainless steel sealing washers, and they have a PVC sealant seal. They're rated for high pressure, 300 psi. Let's see here. So the description says able to withstand pressure greater than 3000 psi. These one-piece bonded washers create the tightest seal. So yeah, I went with 2 of those in the accompanying hardware and didn't leak from start to finish. So the next thing I want to talk about is the oil coolant separator. So let's go over there and take a peek at the back of the machine, and we'll see what SYIL's solution to separating your tramp oil from your coolant is. Here is the oil coolant separator that is on the back of the machine. And if you look over to the left, you'll see a brass, I think it's brass, you'll see a barbed fitting. And that fitting on the left, from what I understand from reading some posts on the Facebook group, that is where the tramp oil is supposed to rise up and then leak out into a catch bottle. And I've got a catch bottle there, a vegetable juice bottle. And then so that's the reservoir closest to the machine, and the one closer to the camera, that is supposed to catch, from what I understand, I could be wrong, but that is supposed to catch the coolant. And then to the right, it came with a hose already installed, and that hose, again, I could be completely wrong, but from my understanding, that hose, when the coolant in that reservoir closest to the camera, when that coolant rises, it'll come out of that hose and then drain back into the sump into your coolant sump, and then be recouped and then recycled back into your coolant. So far, my experience has been the opposite. I've got tramp oil. I've got fresh coolant going out the barb on the left and then dropping into the vegetable juice bottle that I have there. And then the hose that came with the mill when I bought it, that's pushing out tramp oil. Like I said, I could be completely wrong. Maybe the oil is supposed to be coming out of this hose and be caught here. But, you know, it seems like this is supposed to be the recirculation of the good coolant into the sump to be brought back into the machine. So either way, I think this is a good segue into this NEXJEN oil skimming solution. So let's take a look at this and how I've got it hooked up on the mill. All right, so this bad boy is my NEXJEN Oil Skimmer. It's got a flow rate of 15 gallons per hour. I've got it set up so it pulls directly from the sump next to the pump. It pulls through this lower hose. This coolant rises up. There's an inner reservoir that you can't see here, and then spills over. And then it filters through this lattice work, which is supposed to separate or skim off the oil before returning the coolant into here. So we've got a half-inch hose feeding this unit, flowing through the filtration, and then when it drops into this exit column, it changes to a 1-inch diameter hose, which goes back, is returned to your coolant reservoir. And then these two valves, I don't have anything to catch yet, but these two valves, according to the directions, when you have oil, the oil should sit on top of the unit. When you have oil here, you can bleed these valves to remove the oil. Now, I've read some other comments on the internet and the Facebook page of tipping the unit and moving it. I don't have any oil yet, so I'll have to see, you know, how effective the setup is. Here's the complete setup. I know that it's not very glamorous or pretty, just kind of flopped in there, but it works. They give you a lot of hose to install this. I did not have to install it on the side of this toolbox here. You could put it on either side of the machine. There's plenty of hose. I believe it comes with 84 inches of, it says it comes with 84 inches of reach. Okay, so I could have put this unit on the back side of the mill and then routed the hoses here. But for simplicity, I put it on the left side of my rolling toolbox. I never move my toolbox. It's always there except to clean, which is fine. But in my shop, it's there for good. So this worked out well. It's all in one central location, and it made it very easy for me to install. Now, I bought this NEXJEN system. I looked at several different websites out there, but I ended up buying this from MSC Direct online, and they had, by far, they had the lowest asking price. This unit at the time came in at around $556. And then, you know, the shipping was quick. I had it out here in no time and set it up on the machine. Another reason I bought this oil skimmer is because I wanted something that I could operate on a schedule in case I wasn't going to be using the mill enough to keep the coolant agitated, to keep it moving, you know. I want it to last as long as possible. So I went ahead and this might not be the final location for this, but I went ahead and ran a 3-plug surge protector or extension cord over here. It starts at that wall. Whoa, that's dirty. I know what I need to clean. But it starts at that far wall over there where my internet and switch is, and comes over here and just drops down into this space. In fact, you know, for accessories, 1 or 2 120 volt plugs would be awesome in this space here. But I've got it here. I brought power over here, and then I installed a smart plug. There's a button on the plug, and I have it registered on my phone through an app, so that I can turn this on any schedule that I want. So for example, you could go 3 days a week, spread out throughout the week for, you know, 15, 20 minutes, 30 minutes. You could go every day if you're on vacation. I can just hit this button and it turns it on. Looks like it just turned on. So I can turn it on manually and on a schedule. And there it is draining out of this hose here and into this reservoir. And I don't know if you can notice that. I'm a big dork. I've got some magnets in here to catch the finer dust. These bottom magnets don't have anything at this point. And again, I'm not running huge production. I'm not a huge job shop. But this it really does a good job. These are magnets here too of picking up the finer dust. And then every morning I'll just come in and vacuum that up and start the new day. Better that the small chips get stuck here before going through the system. So that is what it looks like. Cycling through this oil skimmer, in on the left, out on the right, out the drain, and back. I have run this before while running a job yesterday, and it did fine. This was not in any danger of overflowing or flooding this system. It worked great. So right now I'm using this advanced coolant mixture to mix up my coolant. When I first got my mill, I bought a tool package from, boy, what was it? Was it BT30 Supply? I don't even remember the store anymore. I remember the rep or owner was Curtis Payne. He's active on the Facebook group. But it's a synthetic fluid that's supposed to be good for both non-ferrous and ferrous metals. Right now I do mostly ferrous, or have done, because I haven't had coolant. But now that I have some coolant, I'm excited to getting into some more non-ferrous metals like, well, aluminum. Everyone loves aluminum. My only experience up until this point has been with Hanksfurter's coolant, which I liked. I didn't have anything to compare to at the time, but it was very gentle, non-corrosive, had good lubricity, and protected the parts very well, the tools and the parts that came off the mills. This one smells, it's a little stronger. Doesn't smell bad. I mean, when I come in the morning in the shop, it smells like a proper CNC shop now, I'll give you that. But it's a little stronger than the Hanksfurter's. I can't compare it to Blazer because I've never smelled that, or Blosser. I've heard it said both ways. But I've got at least one more charge in here, so I'm going to use this. I pay for it, so I'm going to use it, and hopefully it does well. Now, according to their instructions, I mix this up at a 10% solution, and it took about 5 full buckets to charge this mill. Once I got it in the lines, once I have it running through this oil skimmer, all said and done, it was about 5 buckets. And then I mixed up a 5% solution in this bucket. So I did the bucket method. I put in, I believe it was 4.5 gallons into here, and then added 0.5 gallons of this, mixed, and then added to the tank. I've got, I bought this again at, this one I bought at Ace Hardware, but I was able to measure in exactly how many gallons I wanted here, mark it, which is basically right about where this bucket transitions. So just so I could get a good mixture. So that's how I did it. And then for the last mixture here, I've got it at a 5% diluted solution at 5%. So as this evaporates through, chips drying or hot days or whatnot, I can add to the system. And then at my Tractor Supply store, I bought a brand new bucket, and I bought this lid that, oops, of course it's not going to open for me. Yeah, it just twists open like that, and my coolant is exposed. It's kind of got this opaque color when it's just sitting. It's a clear, I wouldn't say yellow, but off-white color. But when I am running it on parts, it seems to run very clear, very minor bubbling and no foaming. It's working fine. It's working great. The last thing on my list is the machine setup, how I've got it set up in here. So stock, I got this coolant rail right here. It has 3 ports for 3 lock line hoses, and then it has this coolant jet that is adjustable. Okay. I fiddled and fiddled with it. I had so much lock line, and well, anyway, I wanted to come up with a good solution to directing the coolant. In this case, I'm trying to direct it all one direction, you know, to the left and this way and towards the front of the machine for coolant evacuation. Again, I might change this down the road, but this is what I have. I removed some of these lock lines, these segmented sections, okay, and then added them to this first one in the list to make that one longer. For the type of manufacturing, repeated manufacturing that I do, right now this works best for me, and this is the flow that I'm getting. Okay, and that's pretty good. I didn't know what to expect from the pump, but it's perfectly adequate. Let's go ahead and I'm going to swing this camera around to the back side, and we can see that one lock line that's not in position. Okay, so you can see that with the extra segments, I've got that curled down and then pointing in a more downward trajectory towards the spindle. And this is the coolant flow. So then from this side we can see the coolant flow. It's not too bad. You know, every nozzle is kind of getting a different angle. Like I said, it's forward and left of my machine. That's kind of the movement. I'm mostly avoiding my tool setter, which is right there. And depending on what tool holder or what I'm doing, I'm not getting a ton of coolant coming up into the automatic tool changer. This brings me back to the last thing I wanted to talk about, and that is, I don't know how this coolant is going to interact, or I don't know how my probe or my Pioneer tool setter is going to react with this coolant. And I don't know if you can make that out, but I've got a little plastic baggie on there with a rubber band, because you know, you pay so much money for this, you'd hate to run a couple parts and then have it stop working. So I just don't know. I know according to the literature they're rated for coolant. I mean, why would they be on there, right? You get a Renishaw is going to work. But this isn't a Renishaw. This is a Pioneer setup. So far so good on the probe. Still works. I mean, it's a battery hog. It loves juice. And pretty much, you know, as soon as that battery starts losing a little juice, it doesn't want to probe anymore. I've got some pretty good luck. I get some good runs out of it, a couple months before I replace the battery. But yeah, there you go. As far as the tool setter, I'm probably going to design and 3D print something to go over it, and or when I get my surface plate in here and my vices, I have to relocate that anyway, and so I'll reevaluate how to protect that from the coolant at that time. But right now, a plastic baggie works, right? If I had duct tape or baling twine, I'd use that too. So anyway, thanks for tuning in. I hope this might have been helpful for someone. Maybe this was helpful for someone. I don't know. If you have any comments, let me have it. All right, thanks guys. Take care. Cheers. Bye.